Howdy, everybody. We're here for day 22 of Advent to Code 2015. Again, just trying to build up our mental muscles so we're ready for Advent to Code coming up in the next couple months. We're almost done. And again, like I said, I think what we'll probably do is go over some of the comments and thoughts and some of the refinements we can do for each of them. Maybe look at other people's solutions just to get an idea of like more optimal solutions or way to think about anything, any algorithms maybe I missed when we just did like brute force. So anyway, that's kind of the plan going forward. But right now we're on day 22, so let's go ahead and get started. This is Wizard Simulator 20XX. Little Henry Case decides that defeating bosses with swords and stuff is boring. Yeah, okay. I was almost lost for a second there. I was like, I thought we did the simulator, but apparently we're not doing it with sword and a shield. Now he's playing the game with a wizard. Of course, he gets stuck on another boss and needs your help again. In this version, combat still proceeds with the player and the boss taking alternating turns. The player still goes first. Now, however, you don't get any equipment. Instead, you must choose one of your spells to cast. The first character at or below 0 hit points loses. Since you're a wizard, you don't get to wear armor, and you can't attack normally. However, since you do magic damage, your opponent's armor is ignored, and so the boss effectively has 0 armor as well. As before, if armor, from a spell in this case, would reduce damage below 1, it becomes 1 instead. That is, the boss's attacks always deal at least 1 damage. Okay. So similar to before. On each of your turns, you must select one of your spells to cast. If you cannot afford to cast any spells, you lose. Spells cost mana. You start with 500 mana, but have no maximum limit. You must have enough mana to cast a spell, and its cost is immediately deducted when you cast it. Your spells are Magic Missile, Drain, Shield, Poison, and Recharge. Uh-oh. Well, maybe these aren't. Magic Missile costs 53 mana. It instantly does 4 damage. Okay. Drain costs 73 mana. It instantly deals 2 damage and heals you for 2 hit points. Shield costs 113 mana. It starts an effect that lasts for 6 turns. While it is active, your armor is increased by 7. Poison costs 173 mana. It starts an effect that lasts 6 turns. At the start of each turn, while it is active, it deals the boss 3 damage. Recharge costs 229 mana. It starts an effect that lasts for 5 turns. At the start of each turn, while it is active, it gives you 101 new mana. Okay, so we have some effects here, right? We have a missile that's just direct damage, a drain that's like damage and healing, and then we have a shield to protect you for some number of turns, a poison to deal damage over some number of turns, like a dot, damage over time, and a recharge, like effectively giving yourself mana back. Relatively low, actually, although you may need to use it. You get 303 mana. Oh, over 5 turns. Sorry, I was thinking it was over 3 turns. Okay. Effects all work the same way. Effects apply at the start of both the player's turns and the boss's turns. Effects are created with a timer, then the number of turns they last. At the start of each turn, after they apply an effect they have, their timer is decreased by 1. If this decreases the timer to 0, the effect ends. You cannot cast a spell that would start an effect which is already active. However, effects can be started on the same turn they end. For example, suppose the player has 10 hit points and 250 mana, and that the boss has 13 hit points and 8 damage. So we cast poison. Okay, so the boss immediately takes damage, and we decrement the timer. And hits us for 8. On our turn, it does 3 damage again. Now the timer is 4. I cast Magic Missile, dealing another 4. Now it's the boss's turn, and it does 3 damage to him, and he dies because he only has 3 hit points. So he hasn't had time. So the effects happen first, then the boss damage, presumably, or the spell I cast. Now suppose the same initial condition exists, except the boss has 14 hit points. So I cast Recharge. I get 101 mana back. Boss deals 8. I get more mana back. I cast Shield. The shield timer reduces. I get more recharge. It hits me for 1 because I have my shield. Shield timer is now 4. So the shield timer counts down on both turns too, right? Not just, yeah. Like everything counts down on every turn. Recharge provides 101 mana. Now it's at 1. I cast Drain, dealing and healing. Shield goes down on the boss's turn. I recharge now. Recharge wears off. The boss attacks me for 1 again. I still have shield. I cast poison. Shield timer is now 1. It deals 3 to the boss. Boss deals 1 to me. Shield wears off. Poison deals 3. I cast Magic Missile. And then another poison kills the boss. Okay. Where is this going? You start with 50 hit points and 500 mana points. The boss's actual stats are in the puzzle. Okay, so, like before. Oh, I guess it doesn't matter what armor he has because we're casting spells. The boss's actual stats are in your puzzle. What is the least amount of mana you can spend and still win the fight? Do not include mana recharge effects as spending negative mana. Okay, so just each turn that I cast a spell, how much mana did I spend? Okay. Sorry, I just need to think about this for a second. There's a couple ways that I think you could potentially try and solve this. I actually think this is a graph problem. Well, I'll think about that for maybe I'll explain that in a second. But another, like a more traditional like brute force option is you could try and create some rules that say like if I ever don't have my shield on, put it on. If I ever don't have poison on, put it on. If I otherwise cast Magic Missile, something along those lines. That won't necessarily get you like the least amount of mana. So like the reason I think this is a graph problem is maybe the way to think about it is you start right here and your goal is to get right here in the shortest distance. So you're here, boss dead is here. What's the fastest way to get there without you dying? And I think that's a graph problem, right? Like you could imagine, like if you're using like Dijkstra's algorithm, you could say something along the lines of, what are my neighbors? And my neighbors are like each of the potential spells I can cast. And I prefer visiting neighbors or unvisited nodes. I prefer visiting unvisited like frontier, what is often used, based on the least amount of mana spent. And so at any point that I get to the boss is dead, that I'm now at the point where there could be no other smaller solution. Like that's the goal of Dijkstra's, is if you're using a heap, like a binary heap, where you're always visiting the least costing frontier node, you'll get there the fastest. So I can try and show this. I pulled out my thing because I think I might be able to show it in a whiteboard really quick. Although my whiteboard doesn't work. Hold on a second. The whiteboard doesn't work really well on I may have to log in though. Sorry, it doesn't work in Firefox. Too many things going through my mind. So we imagine here's the start and here's the, the boss is dead. I can cast a bunch of spells here, right? I don't know what they are, like magic missile, poison, shield, recharge. There's a bunch of them I can do, and every turn it expands, right? I can do a bunch of them here. I can do a bunch of them here. Some of them will be limited because I may not have enough mana to cast them, or maybe after I've cast poison, I can't cast poison again, right? Until it's like gone out. But the effect is we're going to be creating all these nodes, and if I continually visit like the cheapest node, right? Eventually, I get to a point where this becomes the fastest way, and I may visit a bunch of these over time, but eventually I find the one where the boss is dead, and that one has to be the lowest, because up until this point right here, consider all these other frontiers that I haven't visited yet, those costs are all greater than the cost of visiting this node. So I know that this is the smallest node, and that's like the effect of like doing Dijkstra's algorithm is with a binary heap is you say, oh, I know I will have found the shortest path once I get to my like point, because I'm only visiting frontiers that are shorter. If that makes sense. So I'm thinking that's what we want to do. To do that, this part one may be, hopefully they don't change part two too much, because this part one may be a little effort. I think, well, how do I say this? At a high level, the way you solve a program, like a graph program like this using Dijkstra's, is obviously you need to be able to implement Dijkstra's algorithm, but you need to know a couple things. You need to know what is your start. I mean, we know that we'll have my hit points at 50, my mana at 500, and this is the boss's information. So we need to have like, the start and end point, the start point, and then we need to have the end point, right? And and what I mean by end point is we know we win when the boss's hit points are 0. So like that's like the terminal part of it. That's the sentinel or the check you want to make to say, am I done? And that am I done is the hot boss's hit points at 0 or less. And then I know I'm done. And then the other thing you need to know is, what are my neighbors? So we need to have some function that says, oh, I need to, based on a current state, what are the state of my neighbors? And we have implemented Dijkstra's algorithm on here, I feel like a 20 or 30 times. So I'm inclined to use the pathfinding algorithm. Maybe I can show it to you really quick. Or the pathfinding tool. What's going on here? Sorry. So this is a pathfinding crate, and we've used it before as well. Maybe in another video I can implement it myself, but it allows you to actually run Dijkstra's algorithm. And basically you just here's Dijkstra, and it says, and so again, it will compute the shortest path using Dijkstra's search algorithm. You need to give it the start node, the successors node, and a success function, like a function that says, here's how I've succeeded. So those are the things I think we need to implement, and then being able to, after implementing those, we can run this and it will give us a solution as well as like the minimum cost, right? The cost from going to each node. So that will actually be our answer to the problem, is this part right here. Sorry, this is probably not zoomed in very well, huh? Wait, am I in Windows or Mac? Yeah, so again, we need to have a start. Like, what is the start node? What are our successors? Like, how do we find our neighbors? And then we need to have a success function that says, like, how do we know that we're done? So those are the things we'll need to implement, but then we can just run Dijkstra's to solve the problem. Okay, so I'm inclined to start doing that. And the biggest thing to think about is we obviously we want to do those, but most of this involves like some kind of state, right? So this like n is like the state function, this state thing, and the successors function, this thing right here, you can see it returns an iterator over n and the cost, which is the neighbors, right? So that's kind of the thing we need to be thinking about is, given a current state, how do I figure out what my neighbor states are? And then we can just run Dijkstra's on it. So, I mean, let's just get started. So what does that state look like? Struct state. So we're going to have my health. It's like an I32. My mana, which is an I32. We're going to have boss. What did the boss have again? Hit points and how much damage he does. So we'll have the boss health, is I32, and the boss damage. So like those are obviously like the start things. So let's impl a state, and we will have a new function that you give me input. I'll give you a state. And so we need to just get the last of each of these. 1, 2, 3, 1, 2. So if we just do like let arts equal input dot lines, and then we do self, my health is 50 and my mana is 500, right? I feel like I have to double check these things. Yeah, 15,500. And then the boss health is arts dot next dot split by space dot. Is there a last function? Is this like an ugly way of doing this? Oh, this is not going to work very well because they. So if we do like let health equal arts dot next unwrap split by space. Like I'm just trying to step through the things. So if I just collect the health as this, and then I do the damage like this, and then it would be health 2 dot parse I32 unwrap. And the boss damage would be damage 1 dot parse I32 unwrap. Value of type stir cannot be built from an iterator elements of type stir. Okay. Oh, it's a vec, huh? Like that. Oh, and you make this mute. Like that. Okay, so that gives me my initial state. How do I deal with these effects? I probably just have a timer. Yeah, like I think if I just have a count of each of these, so these 3 effects, I just say how much time do I have left on my shield, and on my poison counter, and on my recharge counter. Do I need to know whose turn it is? Probably not. Well, okay, so there's 2 thoughts to this. Is let me fix this. There's 2 ways to think about it. Is I could have each node be my turn and then the boss's turn. Like each neighbor could be like that set, because the boss doesn't do anything interesting, right? I don't have to make any, like, maybe the way to think about that is I don't have to make any choices about what the boss is doing. So I feel like maybe yeah. So with each neighbor node, the question I just have to ask is, given my current state, do the sum of the 2 turns cause me to win, right? I'm going to cast my spell, do my thing, and then the boss is going to we're going to do all the effects again on the boss's turn, and he's going to hit me. And ooh, that may make, I was just thinking that may make like deciding how much it costs. the thing that's going through my mind is, how do I determine the cost of something? So, like, should I apply, like, the normal rules are apply effects, cast a spell. That means it cost me something. Uh, and then apply effects, boss does damage to me. So if the first apply effects kills the boss, I don't have to cast a spell. Maybe I can figure that out in the thing. There might be a simpler way to do this. The alternative is I can just say, is it my turn or is it the boss's turn? That it kind of like makes the, I mean, there it after I've made my choice, the reason why I'm inclined not to do this, I guess I'd like all of your opinions on it, but the reason I'm thinking about not doing two nodes is because the second node does nothing and there is no choice and the cost is always zero. So like you'd always do that, and then it's just on me to figure out the logic of when um how much did it cost to make the boss die? Maybe it cost nothing, or maybe it cost, I had to cast a spell before the boss died in the turn. So anyway, that's something to think about. I think I'll leave it like this and do like the whole cycle in each state or in each neighbor node. Um, which I guess is probably what I need to do now. Figure out what my neighbors are. So FN. Let's see. This is going to want me to do the successors in their own function. Oh, I need to implement equal hashing clone. And also do debug. Let's just print it out right now to make sure we have it. Mm. 5500, 51.9. That's what I was expecting, right? 5500, 51.9. Okay. So I need to have a neighbors function. And the way it works is you give it gives me a state and I will give it an iterator of states, which a vector is an iterator, and their costs. Okay. So I guess I can just do it in here. Oops. I always call it neighbors. They call it successors. That's, what do you do? Okay, so at each state, I probably just need to say, do I have enough mana? It would be something like, well, first of all, I should do any of the effects. So I clone myself, and then I say like if I spell poison wrong. Poison. So if next stop poison greater than 0, what does poison do? Poison 6 turns, deals the boss 3 damage. So next stop boss health equals 3. Okay. And then recharge. Okay. I also need to do shield, I guess, too, but I it doesn't do anything other than next shield minus equals 1. Oh, this is called recharge. Okay. So now I've done the 3 effects. Now I can say like if boss.health is less than or equal to 0, it's now over, so I don't need to cast a spell. Because this is enough, right? There's I need to return what do I need to return? It's actually a cost. Oops. C, which is 0 ord copy. Okay, so I can use like a U size. So I say if, oh, sorry, it's this. And that's it. It's over. Because I didn't have to cast any spells. Otherwise, so like at this point, the boss is going to get their turn. Or, yeah. We should add our, no, maybe, what's the right way to say this? At this point, we cast a spell. So we'll say, if next stop poison equals 0, and what is the cost of a poison? 173. Then we can, so if it's current poison is not active and our next mana is greater than or equal to 173, meaning we can actually cast it, we can return a new thing where we do the poison, right? So if we say we do like, ooh, I want to have applied the effects again as well, right? But I have to do it after I cast the spells. That's crazy. I should probably have a helper function then where I say fn apply effects itself. I do that here. So here I then call poison dot I need to subtract the mana. And then I say poison dot poison equals, how long does it last? 6 turns. And then I do next dot up, or sorry, poison dot apply effects. And then I do neighbors dot push poison. Something like this. Oh, I need to push. I need to add the cost. Like that. Okay, so now I'm kind of inclined to call this something like this, because I'm basically going to do the same thing for poison, recharge. What does the recharge cost? 229. Lasts for 5 turns. Ooh, in all these cases, I need to subtract them. Oh, I can actually just do this up here. I can say like if self.health less than or equal to 0, return empty vec. Like if I'm ever at 0, then it hasn't done any good. I think so, yeah. I'm just trying to think about the order of the algorithm, right? Because it's going to visit a node and it's going to say, is that node a success function? And it should only be a success if the boss's health is at 0 and mine is not at 0. I mean, I guess that's the easiest check, is to say, is the at 0 and I'm at 0. Okay. Yeah, I'll just add that to the success function. But I definitely don't want to continue down a path if my health is less than or equal to 0. Or if the boss's health is less than or equal to 0, like I want to return this path because I've clearly found a good one. Okay, so recharge does this. I actually think I need to do the like so I spell dot health minus equals match spell dot shield greater than 0. If it's true, it does boss spell dot boss damage minus 7. Is that right? No, not here. Armor is increased by 7. Dot max 1. Oh, do you know what? I should do this in the next right here before I do anything. So set my health here. Ooh, but I may have cast recharge. Yes. So the idea is if I have recharge active, I want to take less damage. Remember, I'm doing my turn and then the boss's turn. So in my turn, if I've cast recharge, that may have changed how much damage I would take. So I do need to do it. Here, I think. This is going to look ugly. There might be a simpler way to do this, but at least what's going through my mind now, well, I'll have to think about the logic more. But I need to set my health to be this, I think. So my new health is my current health minus, if I have a shield, spell damage minus 1, max 1. Otherwise, sorry, boss damage minus 7. Otherwise, just do the boss damage. There's probably a better way to do this too, but we'll see how much time we have. So I want to do this here. So I do it for recharge. Sorry, poison, recharge. Now I need to do shield, drain, magic missile. Shield is 113. It lasts 6 turns. $229 recharge. 173. Okay. So now I just need to do magic missile and drain. So magic missile is 53, does 4 damage. Like that. There is a lot of overlap here, so I kind of feel like I ought to maybe do something, but we'll see. So if next mana is greater than 53, then I can add this magic missile, which costs 53 mana. Boss loses 4 health. I apply the effects. I do the same thing. Okay. And so now I need to do one more for drain, which costs 73 and is +2 -2. Like that. Okay. I kind of want to go through the neighbors after the fact and change them, like for these parts. Okay, so if the boss dies, we just return the value. Otherwise, we add to our neighbors, casting each of our possible spells. Poison, recharge, shield, magic missiles, and drain. I am gonna try and do this. Neighbors.iter. For each n, we're gonna do n.apply effects. Then this. This isn't like. Oh, I do this. Okay, so I basically like I for all of them I'm gonna apply the effect and then do my health reduction. Meaning if I have a shield, if my shield is greater than 0, I do this. So I can get rid of like this part in each of them. Nope. Like this. So if I have if I can poison and I have 173, I spend 173, set my poison to 6. Okay. Recharge. I up my recharge. Shield. Shield. Magic missile just does 4 boss health. Drain. Boss -2 +2. 73. Okay. I feel like this is a good neighbors function. The problem is if I apply effects here, oh, I should say this, like if n dot boss health is less than or equal to 0, return something like that. Is I won't have, the boss won't deal me any damage, so I don't have to worry about this one. I just return. I think that will do it. Like what I'm thinking is what if we both die on the same turn? I may be overthinking some of these things. We'll see. They may not be necessary. Um, sorry, I had to read something really quick. Okay, so I have a neighbors function, and now I think I can just use pathfinding crate. So we have our start state, and now we can do you can say like let cost equal path, or sorry, dikes. Not gonna find them. Where is it? Directed Dijkstra. So I need to give it the start, which is start. And I need to give it my successor's function. So you give me a state, and I return s.neighbors. And then the goal is given a state, s dot health greater than 0 and s dot boss health less than 0 or less than or equal to 0, something like that. I think Then I return cost. A size. Okay, what doesn't it like? I'm just gonna assume it's gonna work. $900. That's a funny number. I mean, it does solve it. You ever get freaked out when your number's too normal? Oh, but it's right. Okay. Okay, so what was this in part 1? Most of it was just implementing the logic of the game in that we need to find a neighbor's function to do all this stuff, right? And, not very, I don't know, not very fun. I guess if you're into like game programming and thinking about orders of how everything works, and how to deal with effects and stuff like that, maybe it's a little interesting. I skipped past the Dijkstra's part, right? I'm just using this existing tool to do it. So maybe that's cool or maybe it's not. I don't know. Um anyway, let's move on to part 2. On the next run through the game, you increase the difficulty to hard. At the start of each player turn, before any other effects apply, you lose 1 hit point. If this brings you to or below 0 hit points, you lose. With the same starting stats for you and the boss, what is the least amount of mana you can spend and still win the fight? Okay, so I need to update my neighbor's function to like if I ever hit 0, or sorry, at the beginning of each turn, each effect, I lose 1 life. Do I just add like a hard bool? And then I say like if hard self self equals 1. Ooh, I should probably do it here. It doesn't like it because I'm changing. Oh, I can do this part up here. Like this. And I think that still works. I mean, this will do weird stuff on the last case, but or may do weird stuff. Okay, so for part 1, say false. And part 2, we say true. Oh, it's gonna, yeah. I foresaw it. So let's just make sure that's right. Nothing changes except that if hard is set to true, I decrement my health 1. Okay. Well, that very much changes the game. Okay, but that's the right answer. Okay, not too hard. Again, depending on who you are and how you're feeling, this may feel like cheating. Maybe I can go back and like actually implement Dijkstra myself. If you've done it before, it's not too difficult. Although I think I've done it live a couple times and had to like fix some bugs. But like the gist of it is you have a frontier, which is like a list of nodes that you need to visit. and you just say, and you keep it in a binary heap in Rust at least. You heap sort it by cost, being the lowest being the top, and you basically say, okay, um, give me the lowest cost thing off of it, and then you say, uh, does this is this thing uh, the final state, like the success? And if it is, you're done. If not, you say, what are the neighbors of my current state and their costs? And then you add them all to the thing, all to the heap, and you put them back, and then you continue onwards, right? You also keep track of like a visited list. So if you ever get to a state you've been to before and that state is higher, or sorry, that state is lower, you've already seen it before, or sorry, higher, you've already lower, you've seen it before, and there's a faster way to get there, so you don't need to add it to the list. But if you do find one that's lower, then you should add it to the list, because now you've found something more interesting. So that's essentially how you implement Dijkstra's. Again, maybe we can do that sometime. Okay, so for, I don't know, like like I feel like we're tracking our state pretty good. We did do a helper function to apply effects. You actually see this a lot, especially if you've looked at any game programming. You don't have like a necessarily apply effects function, but you'll see a lot of this. Like, if you usually have like a list of effects, and then you iterate through them, and often those effects are sorted by like precedence, because some take precedence over the others. This is for turn-based, right? If you're doing like real-time ones, uh, then like it's usually based on a tick, right? So the question is like, does the tick happen? If it does, um, do the damage or apply the thing. Um, anyway, you apply the effects like this, and then the rest of the system will decide things like, did the person die or is the person alive? We kind of have to do that all in this neighbors function, which may make it this is like apply effects and check for my own death. Like, that's this part right here. If the boss died, we don't need to cast any spells, so we're done. Otherwise, we cast a spell. Apply boss damage if boss isn't dead. This is also apply effects and then boss damage if boss isn't dead. That part, right? So I actually don't think this one is too bad, because you're doing each of these. You could argue maybe for a keeping these in some kind of vector, and then just looping through them. How would that work? You'd need to have the mana cost. I don't know if it'd be much easier, because you need to have the mana cost and then some kind of function that checks if you can cast it, first of all, as well as like, here's the effects you need to apply. I'm honestly surprised that it worked first time. I don't know if you thought back, but I remember 2 minutes ago. I'm a father of 5, so sometimes that can be hard. But when I first ran it and got 900, I was a little leery, because I'm like, seems too even. I don't know. But the problem is like, when you do these, sometimes you get a number wrong. That's why I like tried to triple check the numbers. But it's also like, oh, maybe there's a minus or a plus. Those things can be hard. So it may be too, like, what you could say is, if you were doing this in an actual game, or if there were much more spells, you may just have, maybe you do create a spell structure, and you say, hey, you give me like a state object, and I will mutate the state. And you could do things like and the maybe the way that you apply those things have features like they say mana minus 229, set recharge to 5. So you have like very strict rules that are more human readable, like a domain specific language, but it's in code, right? And it translates it directly to like what it should be. Anyway, yeah, I don't know that there's anything else that I'd change about this one, especially just because there's only like 5 of them, so you just do them all. I could see one gotcha being like maybe not thinking about like having to try all of the spells, right? Obviously, you can't do spells that you don't have enough mana for, but trying all the spells. Okay. I mean, there's day 22. Not too shabby. Um, Let me know how you did. Love to see how you solved it. Maybe there is some other way to solve it. This is one where you might be able to do it by hand. I know some people like to try and solve some of these by hand. Um, there may be a pattern where you can say, oh, it's fastest to um, cast poison and do bolts as long as you have health. And then at some point figure out when is the right time to cast shield. Anyway, I won't worry about that too much, but if you have a solution, I'd love to see it. I guess all as I'm trying to say. Otherwise, we'll talk to you or we'll see you for day 23. Bye, everybody.